So here we will start with the topic current. What do you understand by current? For conductors, for metals, I can define current as flow of, conventionally we define it as flow of positive charge, is called conductor. The amount of charge flowing per second through a cross section is called current. Let me consider a conductor. Suppose this is a cylindrical conductor. This is a cylindrical conductor. Now, suppose this is a metal. Metal has got a free electrons. They've got a free electrons. The electrons can move freely inside the conductor in the whole lattice. The electrons can freely move in the whole lattice. Right? They are free electrons. If I am not connecting to this conductor any battery, the electrons will move under the effect of thermal motions. See, thermal K. Each particle at temperature T has got a K of 3 by 2 K, 3 by 2 KT, where K is the Boltzmann constant, right? So this energy at room temperature is good enough to move these objects, move these particles, since the particles are having very small inertia. If I equate it to half mv square, you will have this velocity. So they are moving randomly, they are moving in arbitrary directions, right? They are moving in arbitrary directions, randomly. We call it randomly. The motion is random. Every particle, every electron is moving in its own fashion, right? So they move randomly. See, this K may not be enough. See, if I have a sodium existing as sodium plus, electron minus, like aluminium exists as aluminium 3 plus aluminium 3e minus. So this 3 by 2 KT may not be enough to move these objects. They are at the lattice point. They are located at the lattice point. So this thermal K is not enough to move these heavy metallic ions, but they are enough to move these electrons. So this electron keep on moving. They have got a random motion. They move randomly, right? So if suppose I draw a conductor over here, I'll use the green pen. Say I draw a cross section over here. If I draw a cross section like this, now what do you say about the number of electrons moving from left to right, and what do you say about the number of electrons passing through the surface from right to left? See, can I say this, that for every electron moving from left to right across the surface, there exists an electron moving from right to left? Can I say this? See, if there is 10 electrons, I can't say this. But the electrons, the number lies in the range of 10 to the power 23. So at such a range, the probabilistic statement can turn out to be exact. Probabilistic statement can turn out to be exact. See, the number of electrons are very huge. So I can say for every electron moving from left to right, there exists an electron moving from right to left. Since the motion is random, every electron is identical, the number of electrons are very huge, very large. See, probabilistic statements or probabilistic calculation or probabilistic predictions turns out to be very accurate at large numbers. See, where do you have a use of probability in physics? See, probability is basically useful at two places. One where you have uncertainty, other when you have large numbers, right? So probabilistic, it's a probability, statement probability. When I say for every electron moving from left to right across the surface, there exists an electron moving from right to left. I hope you understand. So I can give an example where I can substantiate this. Suppose you have one coin. You have a coin with you. You are this person, and you have a coin here. You toss this coin, right? What is the probability of getting head? What do you say? A personal probability, you can say the probability of getting head is half. Is it a useful statement for you? Does it help you in predicting the result? Does it help you in predicting this result? Does this information, the probability of getting head is half, does it help? If you are a cricket captain, does it help you in predicting the toss, the result of your toss? It may not be. It is not. This is not a useful statement for you when you are tossing one coin, right? But now let's suppose you toss 1000 coins at a time, or you toss one coin 1000 times. Either you have 1000 coins and toss it together, or you have one coin in your hand and toss it 1000 times, right? Now what will be the number of heads? You will say number of heads is 500 based on this information. That probability of getting head is half. You get 500 heads. If you don't get 500, you will get 450. But then this is near to your prediction. Here if you predict head, you can get tail. The error can be 100%. But here if you predict 500 by the probability statement, the result can be 450, or let's say 550. The percentage error can be reduced to 10%. Is it not? You predict 500, it comes to 450, or it comes to 550, even less also. So you find that probabilistic statement turns out to be very correct when you deal with 1000 coins. If suppose you deal with 1 lakh coins, how many heads? Say 51,000 maybe, or say 49,000. If you don't get, by the probability you say it is 50,000. By the knowledge of your probability you will say 50,000. Error can be say 1,000. In percentage term it comes to 2%. So when you move to 1 lakh point, your error will be roughly around 2%. So what do you see? You see that as you go on increasing the number of events, the probabilistic statement is giving you good results. If you go to this range, 10 to the power 23, it's a huge number. I haven't seen such a number. I haven't seen such a number of objects at a time. 10 raised to the power 23, more than even the number of stars and galaxies. 10 raised to the power 23, right? So for such a number, the statement, if I toss this number of coins, I can be very sure that half of the number of coins will be so heads. So you see that if the number becomes very large, the probabilistic statement gives you a correct result. So same I can say over here. The number of electrons are so huge and the motion random. So I can say for motion of for every electron moving from left to right, there will exist an electron moving from right to left. So if I say this, and this will be good prediction, the statement probability will hold good because number is very large. So I can say, if I ask you a simple question, then what is the number of amount of charge passing through the surface per second? We say 0. Why? Because for every electron moving from right to left, there exists an electron moving from left to right. So the number of electron moving, the net amount of charge which is moving across the surface, passing across the surface, is 0. So your I is 0. Means random motion does not generate any current. Random motion does not generate any current. Now the same thing if I put a battery. So when you don't have a potential difference applied across the conductor, you don't have any current. Now let's see what happens if I connect a battery across this conductor, right? See, if I connect a battery across it, what this battery is going to do? This battery is going to generate an electric field in this direction, right? This field is going to generate an electric field. Say the battery is of EMF E. So what battery does? Battery generates an electric field inside, right? We have the electric field getting generated inside. This electric field will exert a force on each electron, which is given by minus E by M. So the electrons are going to get a velocity in direction opposite to the field, right? This velocity will be same for every electron and will lie in same direction. this velocity is going to lie in the same direction. Each electron will experience a force in backward direction. Each electron is going to experience a force in backward direction, right? So that's going to generate a velocity which we call drift velocity. The drift velocity can be written as E by m tau, where tau is called relaxation time. We call it relaxation time. What is relaxation time? Relaxation time is minimum time interval. It's a time interval between average time interval, you can say. Time interval between two successive collision. It's time interval between two successive collision. Collision with whom? Collision with these ions. See, the electron will seldom collide. They won't collide quite often. Very rare happening. Electronic collision, right? Now both are positively charged, both are negatively charged. So they rarely collide with each other. But they can always collide with the ions. And when they collide, they lose all their kinetic energy and they stop. So they get accelerated for this time. This is the average time interval between two successive collisions. So the drift velocity developed is E by m into tau. This is the drift velocity which is developed. What will happen to random velocity then? What will happen to random velocity? Will it vanish? Will it vanish? When I ask this question in classroom, most of the people say yes. Why should it vanish? Why should it vanish? Has the temperature gone? No. Temperature is still there. When temperature is still there, there will still be random K, thermal K. So random velocity draws sustenance from temperature. So till the temperature is finite, temperature is non-zero, temperature is greater than 0, you have the random velocity. So random velocity will be there. Now the velocity of each electron is VR plus Vd. It is superposition of random velocity and drift velocity. Still, every electron has got a random component. Every electron has got a random component which is shown by the blue lines, blue vectors. Green one is showing a drift velocity which is same for every electron, which is going to be same for every electron. So every electron will have a random component, will have a drift component. Drift component of every electron is lying in same direction. Random component will be obviously random. The name is random. So they are in different direction. When I come to current, if I draw again the same cross section, then earlier also this random component, random velocity, was not contributing anything to the current. If I talk about current, I talk about a system of electrons. So earlier means when there was no battery, the random velocity was not contributing anything to the overall motion of the system of electrons. And now also they won't contribute. It will be only drift velocity which will contribute to the motion of the electronic system as a whole. It will be the drift component only which will be contributing to the motion of the electronic system as a whole. So the current will consist of in the current it's only Vd which will contribute and not VR. VR was earlier also not contributing anything. Now also it won't contribute. Right? So Vd contributes to the current. Vd is contributing to the current. Now let's try to get the expression of current. Current is the amount of charge flowing across this per second. Right? So first of all tell me what is the number of, if I call it say cross section, what is the number of electron passing through this per unit time. The number of, see, the electron travels the distance of Vd in 1 second. So I can say in next 1 second all the electron which are lying in a cylinder, you can say a cylinder consisting of, in this cylinder, all the electrons which are lying in this cylinder is going to cross this S in next 1 second. All the electrons which are lying in this region, cylindrical region of length Vd, is going to cross S in next 1 second. So electron which is at a distance more than Vd may not be able to get to this S in next 1 second, but all the electron will get cross this S in next 1 second, all those which are lying in this region. So what is the number of electron lying in this region? It's N A Vd. N is the number of electron per unit volume, A is the area of cross section, Vd is the velocity. And if I ask what is the amount of charge passing through the surface per second, you write minus E. But then, my dear friend, current is the flow of positive charge. For every electron flowing towards left, it can be seen as equivalent positive charge moving towards right. So if I accept the definition of current as flow of positive charge, then the amount of equivalent positive charge flowing through S towards right is going to be this into E, and that's going to be current, right? Actually negative of it is flowing through S, but conventionally I will say the NEAVD is the amount of current flowing through S. So the expression of current is NEAVD. I can define a current density as I upon A, that can be seen as NEVD, or I can write NE. What is VD? I write here, this is a vector. See, current is not a vector, but J is a vector. So like vector form I can write like this. VD can be written as EE by M tau, positive charge. If it is a negative electron, I write like this, minus EE by M tau, right? FE. This one not FE. See, FE was EE. This was FE was EE. The acceleration was minus EE by M. I commit a mistake over here. Acceleration was EE by M. So this is NE squared tau upon M into E. This is your current density, and this is called sigma. Sigma is called conductivity, NE by M tau. If you pass an electric field, if you draw a battery, if you connect a battery, this creates an electric field which is giving you this J. I can write this as E equals to 1 by sigma into J. This is 1 by sigma is written as rho J. So if I have electric field E inside, this is the J, depends on what the resistivity. This rho is called resistivity. We call it resistivity. This is called resistivity. So it decides what will be the amount of current generated where electric field is applied, electric field is produced inside conductor. This rho is going to decide how much current will be generated. E equals to rho into J. This is nothing but, J equal to sigma is nothing but, it's a microscopic form of Ohm's law. Microscopic form of Ohm's law. The microscopic form of Ohm's law. You can get the famous expression V equal to IR for the cylindrical conductor, like you can get it. See, if this cylindrical conductor is having a cross section area A and the length is L, and see J equals to, or you have the similar expression, E equals to rho J, you can write it as E equals to rho J. So if I write EL, this is rho L, when I take A downward, say JA, now what is EL? EL is potential difference. E dot dl from it, this point to this point, is potential difference, rho L by A into JA is I. So you get V equals to IR, where R is called resistance, which is equal to rho L by A for a cylindrical conductor. I consider a cylindrical conductor of uniform cross section length L. For that, resistance is given by this, rho L by A. This is the expression of resistance. This is the expression of resistance. Alright. I hope you understand till this. This is macroscopic formula which you have read in your school. V equals to IR. See, these are just cause-effect relationship. E is the cause, J is the effect. Potential difference is the cause, I is the effect. Right? So these are just cause-effect relationship. I'll do one or two questions on resistance and then I'll move further.